Good morning friends, welcome back to Parnika tutorials. In this video, I want to discuss about the basics of the double-ended queue and also its applications. So I request everyone to watch the complete video for better understanding. So I will give an overview about the queue, then I will discuss about the double-ended queue, and then I will discuss various types of double-ended queue such as input restricted double-ended queue, output restricted double-ended queue. Then I will discuss what are the operations you can perform on the double-ended queue, how it will be performed. Then I will discuss the applications. So let me give an overview about the queue. Queue is a linear data structure where the operations such as enqueue, dequeue, and display will be performed in a certain order. What is that order is, the queue follows the principle called first in first out principle or last in last out principle. Okay, so we will have two operations such as enqueue and dequeue. Enqueue is denoted as inserting an element into the queue is called enqueue. Deleting an element from the queue is called as dequeue. We will have two variables called front and rear. The front will be pointing to the first element in the queue and rear will be pointing to the last element in the queue. If you are implementing the queue using the array, front and rear will be equal to -1 initially. If front and rear is equal to -1, then you can say that queue is empty. Okay, if you are inserting the elements or enqueuing the elements into the queue, okay, you will enqueue them from the rear. Okay, is it clear? So these are the elements I have enqueued from the rear. So first I have enqueued the 2, then 3, then 4. So front will be pointing to the element 2 and rear will be pointing to the element 4. So now front is equal to 0 because you know that array index will always start from 0 and go up to size -1. So rear will be equal to 2. Is it clear? So what I want to highlight here is that in the queue, from one side you can perform the enqueue operation and another side you can perform the dequeue operation. But when you come to the double-ended queue, okay, you can perform the enqueue operation and dequeue operation from both the directions. See, you can perform the enqueue here, you can perform the enqueue operation, here also you can perform the dequeue operation, then here also you can perform the dequeue operation. So you are performing the enqueue and dequeue from the front and also from the rear also. Is it clear? So this is the better one as compared to the queue, because here you can perform the enqueue operation and dequeue operation from the both the directions. So what are the four operations we can perform is enqueue from front or enqueue at front, anything you can write. It is a user defined function, so whatever the name you want to give you can give. And enqueue from rear, okay, dequeue from front, okay, dequeue from rear. Okay, these are the four operations we can perform. Let me discuss how can we perform these operations. Let me consider that I have considered an array called A of size 5. If it is an array of size 5, you know that array index will start from 0 and it goes up to 4. Is it clear? Now, initially when the queue is empty, front and rear will be equal to -1. Okay, now let me discuss enqueue from front. You want to enqueue an element from the front and someone has given the value enqueue from front. I will write in a shortcut as EFF, okay, with value 20. Is it clear? Now look at here. As the queue is empty, dequeue is empty, we can insert this element, and this element is the first element and the last element. So what we will do is that we will make front and rear is equal to 0 and the array A at index of the front, we will assign the value 20. So what is the value of front? 0. So at the index 0, you are inserting this element 20. So now front and rear pointing to this only element. So this is the first element and this is the last element. Now someone has asked you to again perform the enqueue from front with value 30. Now before 20 you want to perform, that is what enqueue from front is, that before this one. Is it clear? Now if 0 is there, what will be the next previous value? It will be -1. But array will have an index called -1. No, it is not possible, because always the array index will start from 0 and go up to size -1. Then can we say that no, we cannot insert? Can we say? When we can say we cannot insert, whenever the double-ended queue is full, then only we can say that it is not possible to insert the element. But these locations are empty. There are no values here. So you can still insert. But how can you insert is, you have to consider this array as a circular array. Is it clear? So the array index is 0, 1, 2, 3, 4. So as you are inserted the element 20 here, before that, so at the index 4 you need to insert the element 30. So at the index 4, so what you will write is that if front is equal to 0, if someone is called enqueue from front, then you have to make the front is equal to 4. Okay, you will make front is equal to 4. At that index you will insert the value 30. So now front is here, rear is here. If someone has asked you to display the elements which are there in the dequeue, you have to write like this, 30 and 20. This is the values you should display. Is it clear? Now someone has asked you to again perform enqueue from front, okay, 40. Now what you need to do? You need to insert the element here. So what you will do is that these two cases are different. One is that when queue is empty, we have made front and rear is equal to 0 and we have inserted. If front is equal to 0 and if someone has asked you to insert, then you will make front is equal to 4 and you will insert. If these two conditions are not satisfied, okay, then what you will do is that you will decrement the front. So you will make front minus minus, okay, and at that index A of front, you will insert the value 40. So here you will insert the value 40. Now front is equal to 3. It will be pointing to this one. If someone has asked you to display the elements, you should display from front up to rear. So 40, 30, 20, it should be displayed. Is it clear? So I hope you have understood enqueue from front. If you still have any doubts, don't worry. In the next video, I will give the entire C code for you. Now enqueue from rear. So rear is here. Okay, you want to insert an element here. Is it clear? Next you want to insert. So what you will do, you will simply make rear plus plus. Okay, rear plus plus, and at the A of rear, you will insert the value some 60. Okay, so 60 will be inserted here. Now rear value is 1. It is pointing to this one. So what are the elements are there here? If someone has asked you to display, you should display 40, 30, 20, 60. Again, someone has asked you to insert an element from the rear. Suppose let's take that they asked you to insert 100. Again, you will perform rear plus plus. Rear value will become 2. Then you will write A of rear is equal to 100. Is it clear? So like this, you will perform the enqueue from the front and from the rear. Even when you are enqueuing from the rear, I will discuss what are the conditions what are the cases you need to look at and what is the corresponding action you should do. I will discuss in detail in the next video. Just here I am giving an overview about these operations. Now dequeue from front. You want to dequeue the element which is pointing by the front. So what you will do, you have to delete this element 40. Okay, is it clear? Then what you will do, you will make front plus plus. Okay, so front value will become 4. Okay, so now front is pointing here. So logically you have deleted this element. If someone has asked you to display the elements which are there currently in the dequeue, then it will display as 30, 20, 60, 100. Now again someone has called dequeue from front. Now if you write front plus plus, then front value will become 5. An array of size 5, will you have the index value 5? No. So then what you will do is that if front is equal to size minus 1, then you will make front is equal to 0. Is it clear? You will make front is equal to 0. So whatever the element is there at the index 4, you have logically deleted. Is it clear? 30 is there, 20 is there, front is equal to 4. So enqueue from the front. So you have to delete this element so that the front will be pointing here. So you will make front plus plus. Okay. So logically you have deleted this 30. Is it clear? Are you able to understand? If you know the circular queue, understanding this one is very simple. Okay. Now I want to do the dequeue from the rear. I want to delete the elements from the rear. Now what is the rear value? Rear value is 2, so it is currently here. Now I want to delete the element 100. So what I will do, I will make rear minus minus. So rear value will become 1. Okay. So logically you have deleted this element. Again someone has called you dequeue from rear. Again you will say rear minus minus. Rear value will become 0. So logically you have deleted this element. Now front and rear pointing to the element 20. Now again someone has called you dequeue from rear. Okay. Then you will look at front is equal to rear, meaning is that only one element is there in the cube. Is it clear? Then if you delete it, you have to make the dequeue as empty. So in that case what you will make, front and rear, you will make it as minus 1. Then we can say that double-ended queue is empty. So this is the way you will perform these operations. If you still did not understand, don't worry. In the next video, I will discuss about them in detail. Each scenario by scenario I will discuss, and I will give the corresponding C code also. Okay. Now let me discuss about various types of double-ended queue. We have two types of double-ended queue. One is the input restricted double-ended queue and output restricted double-ended queue. Input restricted double-ended queue. Then second one is output restricted double-ended queue. Input restricted double-ended queue is that there is a restriction on the enqueue operation. Enqueue operation you can perform from only one direction. Is it clear? However, you can perform the dequeue operation from both the directions. So there is a restriction on the enqueue operation. If it is a double-ended queue, you can perform the enqueue operation and dequeue operation from both the directions. But if it is an input restricted double-ended queue, you can perform the enqueue operation from one side. But however, you can perform the dequeue operation from both the sides. So this is about the input restricted double-ended queue. Now output restricted double-ended queue is that you can perform the enqueue operations from both the directions. However, you cannot perform the dequeue operations from both the directions. Is it clear? So this is about the output restricted double-ended queue. So input restricted double-ended queue means there is a restriction on the enqueue operation, and output restricted double-ended queue is that there is a restriction on the dequeue operation. Now let me discuss about the applications of the double-ended queue. Okay, the major applications of the double-ended queue is palindrome checking. I think everyone know what is a palindrome. Okay, suppose let's take that you have taken a string called RILIRIL. Okay, is it clear? Now if you reverse the string, okay, in C programming language we have learned about strrev function. What is it use? It will reverse a string. So if you reverse the string, it will become L will come here, I will come here, R will be coming here, I will be coming here, L will be coming here. So you have taken the original string and you have reversed the original string. Now look at here, the original string is equal to the obtained string, means reverse string. So how can you do it? In C programming language, you can use strcmp function. It will compare the two strings. If it gives the value 0, you can say both the strings are same or matching. Is it clear? If you look at the ASCII values, capital L, ASCII value will be same. Capital I, small capital I, same. So both the strings are same. So in this palindrome checking, we can use the double-ended queue. And another way we can use the double-ended queue is multiprocessor scheduling. Multiprocessor scheduling. Now, what is meant by multiprocessor scheduling? You will have more than one processor. Let me give an overview. Let's take that you have two processors, processor P1 and processor P2. Okay, now each processor will maintain a buffer. Now, if this buffer is designed with the help of the double-ended queue, is it clear? So you can perform the enqueue operations and dequeue operation from both the direction. Now, each processor will execute a process. Okay, now the process will be divided into certain threads, T1, T2, T3, T4 like this, and this is T100, T101, T102 like this. Now here this is the front and this is the rear, front and rear. So this is the buffer for the processor P1, this is the buffer for processor P2. So whenever the new threads are coming, you will enqueue from the front, okay? And if you want to dequeue anything, you will do it from the rear. Is it clear? So what the processor P1 is do, it will start executing from the front. So it will execute the thread T1, thread 2, 2, 3, 3 like that. And it has executed T4 also. Now there are some more also, T5, T6, let's take that. By the time the processor P1 has executed 4, it has completed all its threads. Okay, then what it will do is that it will dequeue the T6. Is it clear? Processor P2 has completed its all the threads. Then what the processor P2 will do is that it will dequeue the thread T6 from the processor P1 and it will enqueue here and it will execute. Are you able to understand? So they are doing the load balancing between the two processors. This mechanism we will call it as A-steel scheduling mechanism. I will discuss in detail about the A-steering mechanism in the operating system course. Okay, so this is one of the application of the double-ended queue. So I hope you have understood about the basics of double-ended queue and how it is different from the queue and the applications of the double-ended queue. If you still have any doubts related to this video, don't worry. In the next video, I will discuss how to implement the double-ended queue using the array. There I will discuss all the operations with the code also. Thank you for watching the complete video. Have a nice day.